Hello everyone and welcome. Today I'll be explaining one of the most important laws in electrical engineering, which is Ohm's Law. So let's get right into it. So what is Ohm's Law? Ohm's Law states that at constant temperature, the current through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance of the conductor. In simple words, it just means the more voltage we have, the more current we have, and the more resistance we have, the less current we have. So basically, the Ohm's law resistance is voltage is equal to current multiplied by the resistance. And if the voltage increases when R is constant, current increases. If resistance increases when V is constant, then current decreases. Ohm's law holds true when temperature remains constant. That's why they say at a constant temperature. So when the temperature is constant, then Ohm's law it's uh, uh, um, true. So like you can see, V stands for the voltage, which is measured in volts. I stands for the current, which is measured in amperes. And R represents the resistance, which is measured in ohms. And like I said in the previous video, this is just the formula. This is Ohm's law triangle. Students use this to be able to properly memorize the formula. So we have V at the top, then on the bottom we have I and R. So the trick here is, if you want to look for the value of I, you want to look for the value of I, you just cover I, like cover that section of I, then we are going to have V, which is on the top, divided by R. If you want to find the value of R, just shed the R part, then we are going to see V divided by I. And if you want to look for V, just cover the portion of V, then you have I multiplied by R. That is one way students use to memorize that equation. So this is a simple circuit where we have a 12-volt battery supplying a resistance of 12 ohms. So in this case, if we are asked to look for the current flowing through that resistor, we already know V is equals to I times R. So in order for us to have I, we have to take the voltage divided by the resistance, which in this case we are going to have 12 divided by 6. Therefore, our answer is going to be 2 amperes. Then we need to explain the voltage, resistance, and current. So now I'm going to start explaining voltage, and I'm going to use water, the water analogy, like we always use to explain this, because water, a lot of people have actually, see how water flows through a pipe or through a tap. So using this analogy makes it easier for people to understand. So comparing the current flowing example to the water example, voltage is like the pressure pushing electricity through a wire. The higher the voltage, the stronger the push. So the higher the pressure, the more amount of water that can flow. So voltage equals to the pressure, which is, in both cases, it is a force that causes, in the case of water, pressure is a force that pushes the water to move, and in the case of electricity, voltage is a force that pushes current to move. And as for the current is the flow of electric charge. More current means electricity is flowing. So in the case of the water analogy, the water itself is the flow and the electric current. The flow of water is the electric current. So the next is resistance. Resistance is anything that slows down the flow of electricity, and this is a typical example. At a certain point, we make the pipe tighter. So when we make the pipe tighter, it resists. It makes it harder for the water to flow, and that's basically what resistors do in a circuit. So when the pipe is wide, we have more less resistance, so water flows easily. And when we have a narrow pipe, we have a very high resistance, so it reduces the amount of water that flows at that point. So resistance is basically obstruction. So now explaining the formula, like we've said already, the voltage is equal to the current multiplied by the resistance, and which emphasize that if the resistance increases, then the current decreases, and if the voltage increases, the current also increases. So let's look at an example that explains that. If we have a voltage of 12 volts and a resistance of 6 ohms, and we are asked to calculate the current, we're going to take 12, which is the voltage, divided by the resistance of 6, and we're going to have 2 amperes. So now in this first case, if resistance increases, current decreases. How are we going to look at that? If we have the same voltage of 6 ohms, then we have a higher resistance, let's say 9 ohms. Definitely the current is going to reduce. And if voltage increases, if we have a voltage of, let's say, 20 volts, and we have the same resistance of 6, the current is also going to increase. So Ohm's law just shows how voltage, current, and resistance are all connected. And for key takeaways, we can just say, like we've said already, voltage is the push, or voltage is a force that causes current to move, and current is the free flow of electrons. Electric current is the free flow of electrons, so that flowing is electric current. Then resistance is like opposition to the flow of electric current. And thank you for watching this video. If you found this video helpful, and for more educational content, please just subscribe and share. And for our next videos, I'm going to solve some examples of Ohm's law, so you're going to properly understand the lesson. Thank you very much for watching, and have a good day.